This lecture is on rectangles, rhombi, and squares, their properties, and using their properties. Here we have a Venn diagram which indicates how a lot of these quadrilaterals are related to each other. And so here we have parallelograms as a subset of quadrilaterals, kites is another subset, trapezoids is a different subset of quadrilaterals, isosceles trapezoids is a type of trapezoid. Now, within parallelograms, we have rectangles and we have rhombi. And so anything that's a rectangle is also a parallelogram. Anything that's a rhombus is also a parallelogram. And then with the intersection of rhombi and rectangles are squares. So anything that's a square is also a rectangle, rhombus, and a parallelogram, and of course a quadrilateral. And what we also see here then is that all the properties that are true for parallelograms are also true for rectangles, or all the properties that are true for rhombi are also true for squares because of the way these sets are. So we've already learned a lot about different properties of parallelograms. Those are all true for all three of the new figures we're going to talk about today. So everything you've already learned about parallelograms would be true for these figures as well. Now, more specifically, rectangles. Of course, just like parallelograms, opposite sides congruent, opposite sides parallel. So more information about angles, but some new information is that these are right angles. It's a rectangle. These are all right angles. Also, the diagonals bisect each other, which is like a parallelogram, but also the diagonals are the same length. And so not only do they bisect each other like a parallelogram, but also they are the same length. And so because of that, I have isosceles triangles here. Okay, isosceles triangles. Now for a rhombus. Again, everything that's true about parallelograms is true for rhombi. Opposite sides congruent, opposite sides parallel. But in this case for rhombus, all four of the sides are congruent. So all four sides congruent. Also the diagonals, they're not the same length, though they still bisect each other. However, for a rhombus, now the diagonals are perpendicular to each other. Other things about a rhombus, besides now that we have these four right triangles in here, is that not only are the angles, opposite angles congruent, and of course consecutive angles supplementary, like in a parallelogram, but the diagonals bisect each of these angles. So that means this one's the same as this, and because opposite angles are congruent, all four of these little ones are the same, and over here, all four of these are going to be the same as well. So a lot more relationships here for a rhombus. So we basically have four congruent right triangles here for a rhombus. Now squares, we said, all the properties of parallelograms, rectangles, rhombus, they're all true for squares. So just to add on a couple things that puts it all together, because these are right angles, because it's a rhombus, and these are congruent because it's a rectangle, then we have basically 45, 45, 90 triangles all around. And everything that was true for those is also true for a square. And more specifically, we can say we've got these 45, 45, 90 right triangles. So now let's use some of those properties. Okay, find the best name, find the measures of the angles. All right, these are all parallelograms, that's given. Now all four sides are the same, so first of all you could say that this is a rhombus. Okay, now just looking at this triangle on the right side, the rhombus is cut in half. This is going to be 54 degrees, we know that because it's the same as this one. This will also be 54, we know that because diagonals bisect each angle. 54 and 54 is 108, 180 minus 108 is 72. For this one triangle, and then this will also be 72 because opposite angles in a rhombus are congruent, just because a rhombus is also a parallelogram. Over here it's a rectangle, and so if this is 18 degrees, we can say this is 18 degrees because these are the same length. We know these have to add to 90, and so angle 1 then is going to be 90 minus 18, which will be 72. Let's see. 18 is 36, so this angle in here is 180 minus 36, which is 144, which will also be that angle because they're vertical. If that's 144, then this angle in here is a linear pair with that, so that's now your 36. And then angle 3 is the one down here, and that will also be 18 degrees. Here we have another rectangle, vertical angle, so that's 106. Linear pair, so that's 74. We know that if we call this x and this x, x plus 106 is 180 because it's a triangle on the left side. So we can write this equation. So 2x is equal to 74, and x is going to be then 37 degrees. So that's 37, and we know these two angles have to add to 90, which makes this one 53 degrees. Back over here, if this is 59, we know that this one's 59 because, again, in a rhombus, the diagonals bisect each of the interior angles. We know this is 90, and we know this is 90 because in a rhombus. We know it's a rhombus because all four of these are the same. We know that the diagonals are perpendicular. I forgot to mention this is a rectangle. This will also be 59 because, again, all these opposite half angles would be the same, and so also these guys are not 59, but they are congruent to each other, these two and these two. And then over here, all four sides the same length. So again, we have a rhombus, 90 degrees, 68, 68, and then this is 90 also. So you do 180 minus 90 to get 90. 90 minus 68 gives us, for this angle in here, 22 degrees. So that's just looking at that triangle over there. So continuing on, parallelogram. These are parallelograms. Is it possible for them to be parallelograms as marked? Well, if it's a parallelogram, fine, then all the sides are the same, so it's also a rhombus. And if it's a rhombus, then this angle's got to be the same as this one, and you can see the way it's marked, it's not. So that's going to be impossible. Over here, opposite angles congruent, that's okay. So that's fine. Over here, if it's a parallelogram, but the diagonals are perpendicular, that means it's a rhombus, so all the sides would have to be the same length, and clearly they're not, so that would be impossible for that to work. Okay, for number 10 and 11, you're given triangle HIJK, and so HIJK, and basically we're given HJ, which is one diagonal, and we're given IK, which is the other. We know in a rectangle they're the same length. So basically, you just have to set these equal to each other. And so we get 3x is equal to 7, so x is 7/3. And then to find the length of each diagonal, well, we know they're the same length, so we plug it back in. Each diagonal is 7/3. Same idea over here. HJ and IK are the diagonals. You set them equal to each other. 3x plus 5 is equal to 5x minus 9. So I will add 9 to both sides, subtract 3x from both sides. So x is 7. And when I plug it back in, I'll get 21 plus 5 is 26. And they're both the same, so they're both 26. All right, now we have a rhombus. We're not going to find the area. We're just going to find the angles for a couple of these. Okay, if this is 29, I know this will also be 29. This will also be 29 because, again, all four of these pieces will be the same. And then this is 90 and this is 90 because the diagonals are perpendicular. This will be 90. Because this is 20, I know that this angle will be 70 because I've got 20 plus 90 is 110. 180 minus 110, 70. And then we know that both of those guys will also be 70.